Hello everyone. In the second part of KMP algorithm, we will try to um, explain KMP algorithm more efficiently with a proper example. So unlike the naive algorithm, KMP avoids rechecking characters that have already been matched. And it does this using a pre-processing table called the LPS array. So what are the steps of the algorithm? First step is pre-process the pattern to compute the LPS array. Then we will use that LPS table to scan the text using the pattern. If there is a mismatch, we will use LPS array to skip unnecessary comparison. And always we will try to keep in mind that we will not backtrack the text pointer. But in the naive algorithm, we always backtrack the text pointer, but here we will not backtrack the text pointer. This is the improvement of naive algorithm, and we will use it in the KMP algorithm. So as an input, we'll take a text and pattern. Text is a string of length n, and pattern is a string of length m. As a result, we will get output um, all positions in the text where pattern occurs. If there is no pattern matched, we will just show pattern not found in the text. So initially, we will compute LPS array. This is the algorithm. So initially, we will initialize len is equal to 0. That means initially, there will be no previous longest prefix suffix. That's why it is 0. And the first value of LPS array will be also 0. And the scan will start from one position. That means I start from the second character of the pattern. And it will continue up to m. What is m? M is the length of the pattern. So if there is a match between pattern I and pattern len, that time we will increase the value of len and save it to the LPS array. Then increment I by 1. Otherwise, if there is a mismatch occur, that time we will check the value of len. Len is the length of previous longest prefix suffix. If it is a non-zero word term, at that time it will go to the previous longest prefix. Okay. So it is handling here by dynamically. So len is equal to LPS len minus 1. In the example, we'll see how it happens. Otherwise, that means if the len value is 0, that time set the value of LPSI is equal to 0 and increment I by 1. When the condition is false, I is less than m is false, that time we will just return the LPS array. Okay. This is our required, this is our input T and pattern P. So at first we have to create the LPS array for the pattern P. So initially the value of len is equal to 0 and LPS 0 is equal to 0 here. Since I is equal to 0, that means Pi is equal to A. Now a scan is started here. So I is equal to 1 and len is equal to 0. That means we will compare P0 with P1, A and B. There is a mismatch occur. If there is a mismatch occur, that time it will go to this section. Here is len is 0. Since there is len is 0, LPSI equal to 0. Set LPSI is equal to 0. Increment I by 1. That is I is equal to 2. Compare P0 with P2. There is mismatch occur. If mismatch occur, we will check the value of len. Len is 0. That means set LPSI is equal to 0 and increment I. I is equal to 3. Compare Pi with Plen. That means compare P0 with P3. There is mismatch occur. If mismatch occur, we will check the value of len. Len is 0 here. If len is 0, then LPSI set to be 0. LPSI set to be 0. Okay. Then increment I, that means the value of I is increased by 1. That is I is equal to 4. That compare Pi and Plen. That means P0 and P4 is compared, and we see that there is a match over. If match occurs, that times the len will be incremented by 1. That means len is equal to 1. And save it to the LPS array. Here, len is equal to 1, and save it to the LPS array. At 4 position, it is 1 here. Okay. Then increment I by 1, that means I equal to 5. So compare Pi with Plen, that means P5 with P1. So P5 with P1, there is also a match of occurs. That's why increment the value of len, that is 2. Pi and Plen is compared. We see that there is a mismatch. If mismatch occurred at that time, it will go to this section. We see that the len value is 2. So this is a non-zero value. So the value of len will be updated. That is len equal to LPS len minus 1. That means minus 1. So in position 1, the value of LPS 1 is 0. So it is set to the len. So now a len value is updated, but the value of I is not updated yet. So go to the next section. So in the next section, we see that the value of Pi and Plen. So the new value of len is 0, and the value of I is still 6. So compare P6 with P0. We see that there is a mismatch occur. If the mismatch occurs, that time it will update the values of LPSI to 0 directly and increment I value. So here the value of LPSI is 0, and the value of I is incremented by 1, that is 7. Here we see that I is equal to 7 right now, which is actually greater than M. So this is going to be false. This condition is going to be false, and we just return the LPS array. So we got the array after completing all of our simulation. This is our final array here. So actually, we need to understand it clearly. What does it mean in the LPS array? What does it mean by those values? Okay, we will see the meaning of LPS array right now. So initially, we see that our text is A, B, C, D, A, B, D. We just build long prefix suffix subarray. Okay. Initially, we got A. So initially, there is actually no prefix and suffix in this text. Okay. If we write down A, only A, there is no prefix and suffix. If we write down A and B, if we scan from the left, we got A. If we scan from the right, we got B. So A and B, there is actually mismatch. Okay, so that's why LPS I is equal to 0 here. If we consider 3 character ABC, so what will be the prefix and suffix? If we consider prefix, then we will got A and AB. ABC is not actually prefix, or ABC is not a suffix. Okay, we just consider the substring of pattern P, substring. ABC is not the substring. A is a substring of ABC. AB is also a substring of ABC, but ABC is not substring of ABC. So we have to carefully notice that. We have to be careful about that, okay? So for the suffix, we'll get C and VC. If we scan from it right to left, C and VC is the suffix. We see that there is also mismatch, no match. That's why the value of LPSI is 0 here. So if we consider ABCD, we got prefix A, AV, ABC, and we got D, CD, and VCD. There is actually no prefix and suffix also. Again, if we consider ABCDA, what is happening right now? We got as a prefix A, AV, ABC, ABCD, except ABCDA. Okay, there are four prefix and suffix. If we scan it from right to left, A, DA, CDA, VCDA, except ABCDA. Okay, so there is also four suffix. We see that there is a character matching A, there is a prefix A and suffix A with length 1. Okay, so with length 1, that's why we got here only 1. That means there is a prefix suffix matching with length 1. Or A, B, C, D, A, B. A, B, C, D, A, B. A, B, C, D, A, B. We got the prefix A, B, A, B, C, A, B, C, D, A, B, C, D, A, except the whole string. Similarly, we got the suffix B, A, B, D, A, B, C, D, A, B, B, C, D, A, B. If you notice that, we got a similarity match AB here and AB here. So in the prefix and suffix, we got AB as a similarity, which length is actually 2. That's why we got LPSI is equal to 2 here. Okay, AB is both prefix and suffix. Similarly, if we consider the whole string right now, ABCD, ABD, we got AAB, ABCD, ABC, ABCD, 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 AB as a prefix, and we got this as a suffix. If we see, there is actually no match. If there is, since there is no match in the prefix and suffix, we put 0 in the LPS array. Okay, this is actually for understanding the whole process of what is actually we are doing here. Okay, I think everything is clear right now. The meaning of the LPS. So we completed the meaning of the LPS array. Now we proceed to the algorithm to find the pattern using this LPS array. So initially, we got the text and we just got the pattern here. We will compare Ti and Pj. Initially, the value of I and j is 0. Okay, we will compare. If there is a match, both I and j will be incremented. So there is a match and move both. That means we will increase the value of I and j, which is 1 and 1. Okay, here. Now, again, we will compare Ti and Pj. If there is a match, move both. That means we will increase the value of I and j. Okay, then again match. If there is a match, we'll move both. That means we'll increase I and j. So value of I and j will be 3 right now. Okay. So we see that this is a flag in text T and in the pattern P, this is D. So there is a mismatch. If there is a mismatch, we have to fall back. Okay. That means we will update the value of J, which is LPSJ minus 1. So in the position LPSJ minus 1, we will got 0. So the value of J is updated here right now, but the value of I will not be updated. So this is new value of J is 0 and I remains 3 here. So this compare Pi and Tj, Pi and Tj compare. There is mismatch occur. This is blank and this is a character. There is mismatch occur. So when mismatch occurs, we will see is that position of j is 0 or not. If it is 0, that time we need to increment I. So here, right now, increment the value of I, j will remain unchanged. So the new value of I is equal to 4 and j is 0. So compare for pj and ti depending on the value of I and j. So we will get a match here. If there is a match, move I and j. So there is a match also right now. Move both I and j. And there is a match also. Move both I and j. There is a match also. Move both I and j. There is a match also. Move both I and j. There is a match also. Move both I and j. So new value of I and j is a 10 and 6. So in that value of 10 and 6, we will compare ti and pj. There is a mismatch occur. If there is a mismatch occur and the value of j is not 0, that time we have to fall back j equal to LPS j minus 1. So in the LPS array, we got this j minus 1, 6 minus 1 in the LPS 5 position, which is 2. So new value of j is 2 and j is actually remain unchanged here. So compare. So it will go to the 2 position of pattern P. Okay. Text is the TI cursor is unmoved, but PJ go to the second position, 2 position of the pattern. Okay. Just compare. There is a mismatch occur. If there is a mismatch occur, again fall back. So which one indicates that we should go to the 0th position of the pattern. So we go to the 0th position and we see that we compare PJ and TI now. There is also a mismatch occur. If there is mismatch occur and the value of j is equal to 0, we have to increment the value of I. So the mean value of I is equal to 11. And now we compare PJ and TI. That means T11 with P0. There is a match occur. If there is a match occur, the value of I and j both will be increment. Yes, again there is a match occur. Increment the value of I and j. Again the again match occur. Um, increment the value of I and j. Again match occur. Increment the value of I and j and compare Ti Pj. Again compare again match occur, then increment ing, again match occur, increment ing. Now there is actually mismatch occurs right now. And the mismatch occurs right now, and the value of j is not 0, then fall back j to LPS j minus 1. So it indicates it will go to the second position of the pattern. That means position 2 of the pattern. So the position 2 of the pattern is C. Position 2 of the pattern is the C. Okay. So now compare this TI with PJ. We see that there is a match occurs. Okay. If match occurs, then move INJ by 1. Then match occurs again. Then go to the next position of T and P. Yes, match occurs again. Then increment INJ again. Compares PJ with TI. It match occurs, then go to the next position of T and P. Yes, again match occurs. So right now we see that the value of new I is 22 and the value of j is 7. So j value of j is equal to the value of the length of p. That means the value of length of p, that is value of m, is 7. When the value of j and m is equal, we will decide or we will found our required position of the return. So we can tell that we found the index is equal to I minus j. That means 22 minus 7 equal to 15th position. In the 15th position, we'll get the return. Now we will update the value of j as well. One is j equal to LPS j minus 1. That is LPS 6. LPS 6 contains actually 0. So new value of LPS will be 0, and the value of I is remain unchanged. Now it will compare the value of TJ, TI with the value of PJ. We see that there is mismatch. If there is a mismatch occurs and the value of J is equal to 0, just include the value of I. So the value of I is right now 23. So 23 is actually uh, greater than the length of the text T. Okay. And and this condition false, we need to stop the simulation. So here, the simulation stop. So finally, we match found at index 15. Okay. We see that actually from the first beginning, we see that we never actually backtrack. We never backtrack the pointer of the text here. We just move forward. Okay, just move forward. We just uh, check the pattern and go to the and not go to the beginning of the LPS arrays. We just compare P and T and just get back to the LPS array. Using the LPS array, we just reduce the comparisons, okay, compared to the naive algorithm actually. The text array is totally checked by one times only. Okay. So this is pretty simple, I think, and if you think this is helpful for you, just make comment. And if you think you want to learn more and more about data structure, you can enroll on my course. I have a course and I give the registration link into my description notes. You can enroll it anytime and you will find it helpful, hopefully. Okay, thank you so much.